We have Justin here today. He is a software engineering manager from SRS who's going to dig in some with srsRAN and the RIC. So here we go, Justin. You're welcome.
So as we've heard, I'm going to talk a bit about the RIC and the E2 and how we use it in srsRAN. So let's do slides. Okay, so this is just a brief overview of the presentation. I'm going to start off by just doing a brief general overview of what the RIC is and what the E2 is, just to set the context a bit. Probably redundant, but just for a recap. Then I'm going to get into how we use the E2 in srsRAN, talk about what's new and what's better, what we've added recently, and talk a bit about the architecture as well. Then I've got a few slides about how users can extend the E2 themselves. And then we're going to talk a bit about integrations and interoperabilities that we've done over the last year. And then we'll finish off with a couple of case studies about how it's being used by researchers. So yeah, what is the RIC and how does it interact with the RAN? So the RIC is basically a network component that can perform monitoring and control procedures across a network, to put it simply. It can do anything from as simple as pull a CQI measurement from a single UE and a single DU to performing load balancing across an entire network. So the key functionality in a RIC is carried out by the xApp. So the xApp is basically a module that uses this monitoring control facility to perform some AI or ML-based optimization upon the network. And as well as the xApp, there's a couple of ancillary components like the conflict mitigation, for example, to make sure that two xApps don't make contradictory instructions to the different nodes. There's the description manager manages the lifetime of the xApp, and there's a security module to make sure that there's no xApps performing malicious actions or extracting sensitive data to a spy or something like that. So the E2 interface is the pipe by which the RIC interacts with the RAN. It maintains a connection with all the different network components. If there's a DU-CU split, they'll have one for each DU and CU, and for the CU-UP and CU-CP if you have a split in your CU as well. The E2 interface is logically split into two protocols. So the E2 app protocol is the transport protocol that manages the actual the moving back and forth of data between the RIC and the RAN, and then the E2 SM is the actual service provider that provides the actual metrics and control services to the RAN, to the RIC. So this is exposed. The E2 exposes the functionality to the RIC by what are called RAN functions. So RAN functions is just a set of capabilities that are being exposed to the RIC by this particular E2 agent, which is located on the RAN. So it's like an advertisement of what's possible to the RIC. So the E2 in srsRAN, what do we have? So we started the E2 development about 18 months ago, which is about 6 months before the last one of these events. And it was driven mostly by an AI-focused research project that wanted to do some metrics extraction and some ML experimentation. So we added it for that. But what we basically did was we took our existing metrics that we were extracting for like logging and for various other purposes anyway, and we just put them into this kind of KPM service module that's part of the E2. And then we added some just simple RC plumbing for the control, and that was kind of all we had at that point. Since then, apart from tweaks and fixes, we've added three major additions to the E2 since then. So first of all, we've added E2 to the CU. So over the last year, one of the big milestones that's been achieved, Ishmael mentioned it, is we've introduced the proper CU-DU split between the CU and the DU, so they're able to be either co-located or distributed different binaries, put on different compute nodes. And so to kind of enhance this, we've also added the E2 agent to the CU. So even if the DU and the CU are co-located or are part of the same binary in like monolithic mode, they will each maintain their own E2 agent and their own E2 connection with the RIC, and are considered by the RIC to be two separate network components. And they'll each separately advertise their capabilities through the RAN function, as I mentioned. So doing this, we kind of generalized the core functionality of the E2 agent, so just to make it usable in both the CU and the DU. So this meant that when we ported it over, all the existing elementary functionality that was enabled in the DU, all the setup, the subscription requests, the removals, they're all now also available in the CU. So everything that the DU could do in terms of elementary procedures, the CU agent can also do now. And then we've added some initial KPMs and initial RC support. So that brings us on to the next major addition that we've made to the E2, which is the introduction of RIC-driven handover. So normally in srsRAN, handover is done in the standard way, is according to report measurements done by the UE. So the UE is sending report measurements on the cell that it's camped on and on neighboring cells, and then at some point a decision is made in the RC to hand over that UE, and that's a normal way handover works. So to do this, we have a mobility manager, which is the single point of contact for executing a handover, and this mobility member will send this instruction into the call stack of the CU, and then the handover is executed there. And we also added, as a testing function, we added this kind of execute handover to the command line interface. So this is as opposed to having to, when you're trying to test handover, actually moving a phone back and forth between two nodes. It's not really a good repeatable way of doing something in a test environment. So we have this way of executing handover on command by putting it into the command line. So this kind of made this was low-hanging fruit for us with the RIC. Sorry, that's actually the alarm on my phone going off, I think. So yeah, this made it easy because we had this kind of public interface for the triggering of the handover. It made it easy to add this for RIC-driven handover. We just introduced a new interface to this trigger handover, and or a new source to the trigger handover, and we gave the E2 agent basically access to this mobility manager, so that when a RIC control procedure comes in and wants to make a handover, it can trigger a handover in the same way as this kind of handover would happen normally. So the runtime configurability of this particular parameter was already kind of enabled in the stack, so it made it easy for us to add this. So just looking at the RC more generally, we added as I said, added the handover, giving us the initial connected mobility control action, and then what we already have there is some actions in the resource allocation control, which allows us to change basically the PRB quota for given slices. What was interesting when we were adding that is despite the fact that the E2 provides for these kind of more esoteric handovers like conditional handover and DAPS handover, it didn't actually have the facility for DU handover, which is what we wanted to do. So the handover procedure, it only had the fields basically for a NG handover, which is not a part of our open source code at the moment. So we had to make some kind of modifications or shortcuts to allow us to do D handover with this RC module, but that was relatively easy to do, as I said, because we had the trigger handover mechanism exposed already. But more generally, the RC is a more difficult service model to support, because as you can imagine, it's a lot harder to change a parameter at runtime than it is to just observe a metric at runtime, because you never know whether or not you're changing the parameter in everywhere that it's being stored in the stack. You don't know, especially these different parameters are not designed to be runtime reconfigurable. They're a lot more difficult to introduce this kind of runtime configurability. So that's the reason why the RC development works at a slower pace than the KPM. The KPMs can be added easily. The RC is not so much. So we're being very careful about how we add these runtime reconfigurable parameters. So the RIC handover is kind of an interesting capability because it really allows for network-wide optimization. Like other RCs, RC controls, like the slice quota, for instance, that I just spoke about, it's more really of a cell level optimization, and it's kind of an optimization that could really be done internally in the scheduler. But what you really get with the RIC-driven handler is like the ability to do like complex applications, network optimizations, like load balancing, like energy saving when combined with the CCC, which would allow you to turn off unused nodes. You can use this kind of traffic steering applications to unload UEs from a underutilized cell and then turn it off and thereby do energy saving. So it's a very interesting capability to add to the RIC. And so that was one of the reasons why we wanted to add it as well. And it's also is one of the key use cases that was added in phase 1 by the RIC Alliance. So it's shown that it's across the board a lot of people are interested in it. So the third thing that we did was we extended the KPM metrics. So of course we expanded some KPM metrics in the CU. We enabled some KPM monitoring in the PTCP, which was enabled by the new E2 agent in the CU. And then we also audited a lot of delay-related metrics across the stack. A lot of our academic partners were really interested in characterizing delay across the different layers in the stack. So we've been focusing a lot on adding this kind of delay monitoring across all of the layers that we support for the E2. And the third thing we've done as well is we've introduced a new metrics manager. So I'll just say a word about the metrics manager now. So the new metrics manager basically allows us to take metrics from any number of metrics producers, so layers, and redistribute them to any number of metrics consumers, so like sinks, the things like JSON metrics, logging, SDD out to the command line, and of course our E2 interface is another one. So this has kind of been designed in such a way that the metrics manager is agnostic of the actual metrics that it's managing. So it's kind of closed for extension. You can add metrics or change the metrics that you're using. The metrics manager doesn't need to be changed or modified because you've changed the underlying metrics. And the metrics manager is also designed in such a way that we'll be able to turn on and off different producers and consumers at runtime. So you can imagine a case where you're running a network in a deployment scenario and you've got the logging turned off because it's more computationally efficient, but then you've noticed that you've got some anomaly in your network and you want to turn on your logging to see what's happening. So this would allow us to temporarily switch on the logging, have a look at what's going on inside the network without having to spin down the E node B and lose connectivity in our network. So, and then turn it off afterwards so we're not wasting this computational resources by logging things for days at a time. So yeah, the last time I gave this talk, I had this UML diagram that was a kind of a comprehensive overview of what the architecture of the E2 was. And yeah, it was a pretty bad way to explain how the architecture worked, because it's just not a very intuitive way to look at code, I find, using a UML diagram. So I'm trying again now. This is my second attempt at explaining the architecture in a simple way. So what I'm going to do is I've kind of got this sequential way of looking at the architecture, and I'm just going to step through the different components that are touched by observing how a procedure is done sequentially, because I think sequentially is a more intuitive way to think about how code works. So yeah, so I'm using the subscription procedure here. The subscription procedure is a good example of looking at how all the different components are touched throughout the E2. The subscription's job is to manage the process of extracting metrics from the stack all the way to the xApp. So a subscription procedure will arrive at this subscription manager, and it will have details about the particular RAN function, the service, the action, and the metric or parameter that the subscription is interested in. And then the subscription managers will then check this against the database of what is allowed by this particular node. It will have set up through the E2 setup request and response an agreed upon set of actions and services that are enabled in this particular connection. And if the subscription procedure meets those criteria, it'll be allowed to continue, and it'll be allowed to set up and create the different objects that it's going to use throughout the subscription lifecycle. So in this particular case, an example is doing a report service using the KPM. So we will use the KPM manager to create create the kind of report object. The report object can have a number of different types depending on the style, which is usually the different styles indicate whether you want one UE or all UEs or UEs that meet a certain criteria. So the description procedure will be allowed to create that object, and then it will take that object along with the measurements provider, which is the object that basically actually interacts directly with the metrics coming out of the stack, and it'll pass the both of them into like an indication procedure. The integration procedure is the actual procedure that sends the message containing the metric to the xApp. So it's managed by the subscription manager. It's launched and owned by the subscription manager, and the subscription manager will basically allow it to run until it receives a subscription delete request, and that'll kill the indication procedure. And this will run periodically depending on what the report period is set by the subscription. So the integration procedure will run every X milliseconds, say. It'll use its report style object that it's created, and then it'll collect the metrics from the metrics provider. The metrics provider, just to note, the metrics exchange between the stack and the E2 agent is asynchronous. So the E2 agent isn't directly pulling the metrics out itself, but rather it's reading from a set of raw metrics that are extracted from the stack and put into the DU provider, and then depending on what the requested metric is, it's parsing and like post-processing that data into the desired metric and with the desired averaging and in the desired unit. So just to say a bit about the other side of that asynchronous exchange is the report metrics function that gets called periodically in each layer. So as I just said, in the metrics manager will manage this extraction of metrics and distribution to the different sinks. In our case, it's the E2 sink. And what will happen is that that raw metric struct will arrive in our DU provider, and that'll store it. And then when a collect metrics function is called from inside a indication procedure, that will be the job of the provider to parse that data into like a format that the xApp wants. So yeah, so now I'm just going to say a few words about how to extend the E2 ourselves. So there's three kind of use cases there are just three kind of types of metrics that you might have to add. So the easiest case is that you want to add a metric that you can derive from the existing raw metrics, but they haven't been parsed into the particular metric you're interested in. But the underlying data is there in the metrics. The raw metrics are quite a large body of data that's pulled out of each layer. So that's the easiest case. The other case is that the metric is sourced from a supported layer, but the information from that layer that you need isn't actually extracted into the raw metrics yet. And then the third case is that you want a metrics from a layer that's not currently supported. So yeah, the good news is that if it's the first case, the easy case, you only need to change one object. As the DU provider, everything you need to change is contained in that one object. So I'm just going to talk through briefly about how you can go about doing that, just as a reference. So the first thing to do is we've created this database, basically. And this database contains all of the possible E2 metrics that are specified by the standard, not the ones we support, but all of them. So there's like hundreds and hundreds in this file. And what we've done is we've filled up this database with the metric names, a primary key, and all the kind of metadata associated with like what kind of, whether it's a DU or a CU, a cell level metric or a UE level metric, and all the other labels associated with it. And we've also put just a plain text description of what the metric is there, and they're all available in this database. So all you need to do is go to this database and read through the descriptions of the different metrics and find the one that closely meets your needs, and then just take that name, and then we go to step 2. We just need to, in this step, add a processing function for that particular metric. So the way it works is the indication procedure will call this generic get measurement data function. And this function is a generic function that is called for every metric. And what will happen is it will use the name of your metric to map a function pointer to the function. So it'll call, depending on the name of the metric, it'll call the processing function for that particular metric. So what you need to do is you need to write that function in the template format of this function. So it's straightforward there. The template is there. You just need to copy it, and like if you're doing something for latency, take all of the kind of latency related metrics out of the raw matrix, add them up in the way that you want, and then return them from this function. And then that's all you need to do. Well, besides this, there's also this array, or this map rather, of supported metrics. So this is just the key, the maps the metric's name to all the metadata about the metric, and then the actual pointer to the function pointer. So you'll just put in this database, or in this this map, the name of the function that you've created, and then all our underlying plumbing will map that function pointer and have it called at the correct time. So yeah, the second case is trickier, and you can't really be explained explicitly how to do it, but I just kind of give a rough overview. So what you need to do if your metric requires some extra information from the layer that you're targeting is you need to go to these report metrics functions that are again in that same CPP file, E2SM KPM, and just look at this structure that's getting pulled in. So whether it's RLC metrics or scheduler cell metrics, you need to look at that structure and figure out what extra information you need to create your metric, and just add that there, whether add a couple of variables that are going to store some delay, or some delay between 2 points within the stack or within the layer that you're going to touch. And then you need to go to that layer, calculate the part of your metric you don't have, and then save it into that variable. But once you do that, all the plumbing will work, and you'll get it to your process function. You'll be able to use it then. You just have to extract the right information from the right part of the stack. And the third case requires you to basically add the metrics manager to a layer which is not supported yet. I'm not going to go through how to do that because there's only 2 or 3 layers that aren't supported, and we're going to add them soon. So you don't really need to worry. That'll be done for you. So yeah, the next thing I'm going to talk about is the different integrations and interoperability stuff that we've done. Mainly talking about different RICs that we've been integrating with. So the 2 main open source RICs are the FlexRIC and the ORAN SC RIC. The FlexRIC is by a company called BubbleRAN. We like it because it's C and C++ based, because we're SDR nerds, we love C and C++. And it's also easy. It's easy to deploy, so it's a single repo, and it can be run bare metal with a single binary, easy to spin up. And the community is also very active and responsive. But yeah, we also worked a bit with the ORAN SC RIC. It's not as easy to use, a bit cumbersome, but the stability is very good, and it's also very widely adopted. A lot of researchers use it, and we get asked about it a lot. So what we decided to do was to try and make the ORAN SC a bit better, or not better, but more suited to our needs as researchers. So what we've done is we've created a new ORAN SC repository. We've kind of stripped out all of the Docker containers that are the different parts of their RIC, and we've gotten rid of the kind of Kubernetes architecture, and we've created our own kind of simpler Docker architecture and kind of glued it together ourselves. And the kind of goal, the design goal of this is to make it a lot easier to deploy, for a lot easier to experiment with. So it should be 1 command to spin up, 1 command to start an xApp, and 1 command to tear it down. And we also want to make some easier to use xApps, because we could never really find any reliable xApps that we could use with the ORAN SC. So on the right-hand side, I've got this list of commands that you need to basically deploy this ORAN SC RIC. I noticed the numbering's gone wrong there. But what we've just got is you have to clone it, cd into the directory, and then it's 1 Docker compose command, and your ORAN SC RIC will spin up, and it'll work. And then in terms of the xApp, we've added a simple xApp framework that you can use with this, and then that deploys in the same way. It's just 1 command, a Docker compose, and then you execute this simple Python xApp runner Docker, and then you pass in your xApp, and we've provided some xApps that I'm going to talk through now. So yeah, with this, we've already added, we've also added like an xApp framework. So it's a nice library. It's got like an ASN1 packer and unpacker all done in Python. We've also included the ASN1 files for KPM and for RC, so you don't need to add anything to it. It'll just run. We've got like kind of base modules for the KPM and RC, and then we've got a nice generic xApp object that does all the kind of setup and teardown. that's required for an xApp. And then we've also given a couple of sample xApps to do monitoring and one to do control. So in the monitoring one, you just need to pass a string of the name of the metric you're interested in, and if it's one of the ones that our RAN supports, it'll pull the metric right out and it should work just out of the box. So all you need to do is put your AI Genius stuff in the middle of this Python and you're away to go. Okay, so here's a couple of case studies of academic partners that have been using our E2 interface and our RICs. So yeah, first of all, AI at Edge, it's a project that finished recently, and it was most of the partners were AI research focused. So we were taking care of the RAN part of the project, and what they did is they created a kind of scenario classifier, an ML classifier that they took kind of 4 different states that a RAN connection could be in, and they ran a classifier based on some KPM metrics, classified based on some KPM metrics they were pulling out. And then they were using this to make decisions at the application layer, like rerouting traffic appropriately. Second one is another publicly funded project for a national project in Spain, and this is with a research group called CTTC and with the Keysight as well. They're actually using the Keysight RIC in this case. And this is doing some context-aware dynamic RAN slicing. So they're viewing some they're viewing some KPM metrics, and then doing some sort of intelligent PRB sizing in their slices. And now that we've added the RIC-based handover, they're going to be integrating that into their use case as well. This is just one of 6 or 7 use cases that uses the RIC in this particular project, but this is just one that's more mature than the others. So yeah, just some final thoughts. Yeah, I'm a big advocate of what the ORAN have done with the E2 and the RIC. I think it has the potential to be one of the most important outcomes of the whole project. I think what's really interesting about it is how it's kind of devolved the expertise needed between AI and ML researchers and RAN developers. Before, if you wanted some AI in your stack, you would need your RAN developers to develop it themselves, or you might need to bring in some third party, but then you'd have to, these tier 1 vendors don't want to be showing their proprietary RAN stacks to third parties, so it's kind of a difficult problem to solve. But now we've created a clean interface between the two, and we're allowing the AI and ML researchers to worry about the AI and ML, and allowing the RAN developers to worry about the RAN, and they're decoupled in a good way. Of course, it's still got some drawbacks. I think the latency, the minimum latency of an action is 10 milliseconds. It can only be carried out every 10 milliseconds, and I think this is okay for the higher layers, but once you start talking about file layer optimization, this is too long. And I know there's actually this was actually a talk I think at this conference about something called the EDRIC, where they're trying to restructure the RIC and the E2 in such a way that they could do 1 millisecond. Just as a note, Microsoft are doing some interesting work with this, something called the Janus framework, where they're being compatible with the E2 in terms of the setting up of the interaction between the RIC and the RAN, but then they're using, in terms of doing the actual critical path stuff, they're using eBPF, which is a kernel space message exchanging protocol, to actually do the time critical stuff and extracting the metrics and pushing in the commands. This paper in InfoComm last year, and it's a good read, and I think they're doing some very good work. And the third thing is the xApps, the vendor-locked xApps. It's a problem. It's a problem for the innovation of developing xApps. So far, there's no clean interface there's no well-defined interface between the xApps and the RIC. Every kind of commercial RIC vendor has their own SDK for developing xApps, but I mean, I don't know why they want to do that, because they want everyone to use their RIC. But the reality is, if you want to see wide adoption of the xApps across the ORAN community, they need to be usable across any RIC. So that ORAN need to standardize that interface a lot better than they have already. And with that, I left a bit of time for questions.
Just a quick question on your last slide. Is the problem the vendor-locked xApps SDKs, or is it that vendors are making their own xApps that aren't necessarily compatible across RICs?
Well, yeah, from what I've seen, they're not cross-compatible, but it's not that. like obviously you could take out the underlying like AI or ML algorithm and put it into any xApp from any company, but they're like the xApp as a function or as like a product and application isn't usable across different RICs. You have to kind of port it. So like, I mean, they're not even written in the same language. There's no API like for you to port it across. Like in the same way as like you should be able to pair any DU with any CU because the F1's standardized. Like the F1, everyone's F1, I know it doesn't necessarily always work out like this, but it should, like everyone's should work the same. Whereas there's no well-defined way for an xApp to communicate with a RIC.
I have two questions about the Docker version of the OSC RIC.
Yes.
So we have been able to use it, and the first question is how different it is compared to the OSC RIC, the Kubernetes version?
Well,
Like a replacement?
no, all the functionality is theirs. Like we're not claiming to have built a new RIC. We're like they have Docker containers for the different like components within the RIC, and they glue them together and they deploy them in Kubernetes. And that's great for like a deployment that you're leaving there forever. But if you want to be constantly spinning it up and spinning it down, making small changes, it's a lot. It's cumbersome. So what we did was we just took out the Docker containers that are the functionality of the RIC, and we just put them back together using Docker, like one Docker container that can be deployed really quickly. And then we've added this kind of xApp, Python xApp library as well. So it's just like they've done all the heavy lifting. We're just making it easier to use.
Okay, great. Thank you. So the second question is we have been able to create the xApp that do the desktop control. I'm wondering if you have been able to like develop the xApp with the OSC RIC, the Kubernetes version to the control. So how difficult it is to convert the Docker version to the OSC version?
Well, I mean, we haven't tried to, like the actual xApp library is what we've written that part. That's written in Python. And the routing, we've used our own routing within the Docker framework to actually get it to the RAN. So I'm not sure whether that xApp library stuff would work with the Kubernetes version, but I would have to ask the engineer who actually wrote that. But I don't think it would work with the Kubernetes version, which goes back to our problem that xApp's been, it's not even portable across different versions of the same RIC. Sorry, yeah, go ahead.
Do you think that would be something that the ORAN Alliance might try to do, is standardize the features for xApps in the RIC? Not saying that people couldn't go past those features, but just having like a core set of features so you could have cross-compatible xApps?
Yeah, and I mean, I think it would be interesting to see the. They're bringing out APIs, are they? Well, that's great. See, I don't go to these ORAN Alliance standardizations. Okay.
I do have a question about
Yep.
O1.
O1, yeah. It's a work in progress. It's something that's in our roadmap, but hasn't been in earnest started, but it is coming. He's going to do it.
It's done next week?
Yeah, in 2 weeks.